Welcome students. Actually in the previous class we discussed about different types of pulley and what is pulley and how pulley is work. Okay. Now today we actually discuss about wheel and axle arrangement. Okay. Wheel and axle arrangement and also know about how this type of arrangement is worked, okay, and also know about care of machines. Okay, so at first the question is what is wheel and axle arrangement. Okay, so as the name suggests, this is a machine, and this machine is a combination of wheel and axle. This type of machine, this, or we can say this machine is a combination of, we can say this is a combination of a wheel and an axle. Okay, and the second point is actually this type of machine consists of a wheel attached to a rod called axle. Okay, so the second point is actually it consists it consists of a wheel attached to a rod called axle. Okay, such that when the wheel is made to rotate, the axle also rotate. Okay, so if we draw a simple diagram, block diagram of wheel and axle, then we find this type of figure configuration. Okay, in this case, this is your actually, this part is actually wheel part, and here this is your center part, and from this wheel actually we draw a axle part like this. This is your axle part. Okay, so here this is axle and this is your wheel part. Okay, and in this case actually when wheel rotates in the direction, we take clockwise direction, then also actually axle rotates in the clockwise direction. Okay, so this is a simple block diagram of wheel axle arrangement. Okay, now the question is how it works. Okay, now the next question is how it works. Okay, so in the most wheel and axle devices, the actual part of the device that needs to be turned is usually axle. Okay, this is the most, this axle is the most actual part. Okay, that needs to be turned. Okay, and it is not easy to turn the rod without an aid. Okay, so it is attached with an wheel which is easily rotated. Okay, this is easily rotate. This part is easily rotate. Okay, so when an effort is applied on the wheel, it easily makes the fixed axis rotate with it, and the force is applied on the wheel, the axle rotates with a greater force. Okay, so actually we apply small forces. Okay, we apply small forces on wheel. Okay, that is easily makes the fixed axis rotate with it. Okay, and the axle rotates with a greater force. The axle rotates with a greater force. Okay, that is why actually wheel and axle work. Okay, so in this part actually there are two parts. One is axle and another one is wheel. Axle is the most actual part, and wheel is the part that is easily rotate. Okay, and actually wheel is applied to rotate axle. Okay, and axle is not easy to turn. That is why we apply small forces on wheel, and it is easily makes the fixed axle rotate with it. Okay, and when a force is applied on the wheel, the axle rotates with a greater force. Okay, now what are the examples? Write down some examples of some examples of wheel axle arrangement. Okay, such as first one is screwdriver. First one is screwdrivers. Second one is doorknobs, and third one is pedals of a bicycle. Pedals of a bicycle, and fourth one is steering wheel. Steering wheels, and fifth one is drilling machine, that is machines that is used by carpenters. Okay, and etc. These are the some examples of wheel and axle arrangement. Okay, in such cases, the rotating spindle tab, instead of a proper wheel, only a handle is attached to the axle. Okay, this handle works like a wheel when rotates. Okay, and we also take the sixth one, that is spindle tab. Okay, so in this case, actually for spindle tab, a handle is attached to the axle. This handle works like a wheel when rotates. Okay. Now we move to our next point, that is care of machines. Okay. So in generally we use machines to solve hard work with the help of small amount of force. Okay, or we can do some hard work more easily. Okay, by using machines. Now we have to know what are the cares of machine. Okay, so here actually we take some cares. The first one is machines should be kept in a clean environment. Okay, that means at first this point is clean environment. Okay, so in this point actually machines should be kept in a clean environment which is free from dust and moisture. Okay, and the second care is in generally machines should be kept covered to prevent the collection of dust on them. Okay, so prevent the collection of dust, the collection of dust particle, okay, on them, on machine, okay. And the third one, which is actually machines made of iron. So machines made of iron should be protected from rust, okay, by coating them with paint, okay. Prevent from rust. In generally machines made of iron, so we have to protect the machines from rust by coating them, actually by coating them with paint, okay. And the fourth one is actually the moving parts of a machine should be regularly oiled with a good quality machine oil to reduce friction and wear and tear, okay. So to reduce friction, to reduce friction, we have to use we to reduce friction we have to use some good quality machine oil, some good quality machine oil, okay, with a good quality machine oil in the moving part of a machine, okay. These are the cares of machine, okay. Now actually this is the end of the chapter machines, okay. But in the last actually we take a simple concept map, okay, that actually help to clear your concept about this chapter, okay. At first we have to know first is what is simple machine, okay. You have to know what is simple machine. Now actually there are several types of simple machines. We already discussed, actually there are total 6 types of machines, okay. So here we draw, this is OH, and you have to know about what is the definition of OH and how it works. And the second one is screw, okay, and you have to know the definition of screw and how it works similarly, okay. And the third one is inclined plane, and the fourth one is actually wheel and axle, and the fifth one is lever, and the sixth one is pulley. And actually in your syllabus or in your textbook, actually pulley is classified into two different segments, okay. First one is fixed pulley single fixed pulley, and the second one is single movable pulley. And you have to know about what is the basic difference between single fixed and single movable pulley, okay. And you already know there are 3 different types of lever. This is class 1, this is class 2, and the third one is class 3. Okay, and also in the liver part, this is there are three different term which consist liver, that is basically first one is fulcrum and second one is load and the third one is effort. And in this chapter you have also know about what is MA or mechanical advantage of a machine and efficiency of a machine. And the second point is efficiency of a machine. Okay, this is the simple concept map. Okay, in this map you can see at first you have to know what is simple machine, then you have to know about 6 types of simple machines, and you have to know about the definitions of all these types of machines. Okay, and you have to know for particular pulley actually what is single fixed pulley and what is single movable pulley. Okay, and what is the basic difference between single fixed and single movable pulley. Particularly for single fixed pulley, fixed axis of rotation, and single movable pulley, we can say axis of rotation is not fixed. And now we move to our simple machine, that is lever, and you have to know what is class 1, what is class 2, and what is class 3 lever. Okay, so in this case actually already discussed before puja vacation. For class 1 lever, fulcrum lies between the load and the effort, and also for class 2 lever, load lies between the effort and fulcrum point, and for class 3 lever actually effort lies between the load and the fulcrum. Okay, and you have to know what is fulcrum, what is load, and what is actually effort. Okay, so what is a fulcrum? Fulcrum is the fixed point about which the lever can rotate. And what is load? Actually the load is the object to be lifted with the help of the lever. And the third one is effort. What is effort? Effort means the force applied on the lever. Okay, and what is the definition of mechanical advantage? Actually mechanical advantage is the ratio of load and effort. That means load is one type of force and effort is also one type of force. So mechanical advantage is the ratio of two same quantity, that is force. So mechanical advantage has no unit. Okay, and what is the efficiency of a machine? Particularly efficiency of a machine is defined as the ratio of output power to input power, or we can say output energy to input energy. Okay, and if we multiply this ratio with 100, then we get efficiency in percentage. Okay, so this is basic concept, or this is a simple concept map about the whole chapter. Okay, that is machine. Okay, and also this chapter is completed. Okay, and in the next class we actually discuss about your exercise problem. Okay, that is your in your book. Okay, now this is the end of today's